Alright, welcome to today's lesson on algebraic fractions, or multiplying and dividing with algebraic fractions. Now we're going to take what we've learned in the last two lessons, or practiced in the last two lessons, and apply them to a different scenario where fractions have pronumerals in them. Alright, so our learning intentions today are to understand the rules of multiplying and dividing, or to understand that the rules extend to algebraic fractions. So whatever we do with original fractions we can do here, and then to be able to multiply fractions and simplify, and to be able to divide fractions and simplify. All right, so the first one is understand that we can. The second two are doing it. All right, so you might remember that from the last lesson that a fraction problem like, that's meant to be a 2. 2/7 equals this, so numerator by numerator, denominator by denominator, 6/35. All right, so multiply those. So when we come to algebraic fractions, we are allowed to do exactly the same. So numerator by numerator, denominator by denominator, multiply. All right, so this will give us 4x times 2y over 7 times 11. Now I've written it like that for a reason that will become apparent soon, or maybe in the next problem. Now to do this, we just multiply the numbers together, so 4 times 2 is 8, x times y is just xy. Because at this point, we're not sure what they're worth. They could be worth anything, but we know that multiplying them means I can just write them like this. Over 7 times 11 is 77. All right, now with multiplying fractions, remember the last step was to see if we could simplify. So we'll have a look. Are there any common factors between the numbers, 8 and 77? The answer is no, so they stay the same. And x, y, we're not sure what they are, so we can't actually say if there's any common factors. And if they're, what we'd look for to simplify them is the same factors on the bottom, but there aren't any x's or y's there either. So this fraction is the answer. It's 8xy over 77. Job done. So we understand that we can do the same things with algebraic fractions as we did with normal fractions. So another example using division is this one. 2x over 5 divided by 3y over 7. So recall that the rules say to change the divide sign to a multiply, take the reciprocal of the second fraction, which means to turn it over, and then go through the steps as per usual. So numerator by numerator, denominator by denominator. So 2x times 7 over 5 times 3y. And this will give us 2 times 7 is 14, times whatever x is, over 5 times 3 is 15, times whatever y is. And the last step, as normal, is are there any common factors between 15 and 14? The answer is no. Are x and y the same number? The answer is no, because they're x and y. All right, so that one stays as is as well, 14x over 15y. Now let's have a look at a few more in-depth examples. All right, so the one we're going to look at is going to involve some simplifying at the end, and here's the question. I'll just move it to the side. So we'll have a look at 2a over 5 times 3b over 7. Is that the one? Oh, no, not the right one, sorry. 4x over 15 times 3y over 2. There we go. Okay, so there are a couple of ways we could do this. I'm going to show you my favourite way first. We know that the answer is going to look like this, don't we? Over 15 times 2. Okay. We also know that our last step is going to be simplifying from top to bottom or bottom to top and asking ourselves, are there any factors of 12 that are also factors of 30? Okay. So we know that 12 and 30 are both even. It could work. What we can do is do the simplifying right at the very start here, because we know this is going to be the second step. So I know to myself that 3 and 15 share common factors. That factor is a 3. So 3 divided by 3 is 1. 15 divided by 3 is 5. I also know that 2 and 4 share common factors. That factor is a 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So now my problem, instead of having 12 and 30 in the answer, my problem looks like this. 2x times 1y over 5 times 1. All right, now this is going to give me 2 times 1 is 2, xy is just xy, and 5 times 1 is 5. So my answer has been simplified already because I cancelled out or simplified at the very start. All right, and I'm allowed to do that. If I'd done it out here at this 12 over 30, I would have said to myself, okay, 12 and 30 share a common factor of, what's the highest number? 6. 6 goes into 12 2 times, 6 goes into 30 5 times. So you can see that I would have got the same answer. I like to do the first way because it means that I'm not multiplying big numbers all the time. If I can simplify them, I simplify them early. All right? So feel free to give that a go if you want to. Another problem we can look at is a division problem. Looks like this one. U over 4 divided by 15p over 2. So again, u over 4, change the divide sign to a multiply, 2 over 15p to take the reciprocal. Simplify if we can. 2 goes into 4 twice, so that gives me u times 1 over 2 times 15p, which gives me u over 30p. So you can see here that in this algebraic fractions that the letters are just staying in there. I'm going to show you an example now of what happens if we have the same letter on the top and the bottom or across the fraction. So it might be an example like this, p over 4 times 3 over p. All right, so to do this, we go numerator by numerator, which is 3p over 4p. Now, there are no common factors between 3 and 4, but p and p, whatever they are the same number, which means that if they share a common factor, and that factor is p. So if I divide them both by p divided by p is 1, p divided by p is 1, you'll notice that they both go. The answer is just 3/4, because they were the same number on the top and the bottom, which means that when I work it all out, they're going to simplify back down to 1. So this answer is just 3/4. All right, so shortcut, if you see the pronumeral on the top and the bottom, and it's the same one, you can cancel them out or simplify them early. All right, and a similar problem would be if you saw it in division. Remember that as I modeled over here, we don't simplify at that step. We simplify when we've taken the multiply sign and found the reciprocal, because otherwise you could be tricked into thinking that that is going to be the numerator, when in actual fact that is the denominator. All right, so in a division problem, you've got to make sure you do it the right way. So the same problem as the one above, you can see here that p over 4 divided by p over 3. If I follow the steps, p over 4, change the sign to a multiply, take the reciprocal, and I've suddenly got the same problem. So p times 3 is 3p, 4 times p is 4p, simplify the p's out, and you end up with 3/4. All right, so to recap, we're allowed to use the same rules for normal fractions in algebraic fractions. We just have to remember to multiply the pronumerals through as well. All right, so xy, or x on the top and y on the bottom, or whatever the pronumeral is in the problem. We can also remember that we can simplify first before multiplying, or we can do it last. We end up with the same answer. We just have to be careful that we only simplify top to bottom. We don't simplify across the numerators or across the denominators. All right, so a simplifying has to happen from numerator to denominator, or vice versa. All right, so give those questions a go and let me know if you need any help.